Good morning, afternoon, or night, whenever you decide to watch this. Today I want to talk about functions. We're going to talk about functions when it comes to points and domain and range instead of finding functions using a graph. We'll do graphs next. But using domain and range, we want to find a function. Well, first off, a function is a relationship between x and y where every input has exactly one output. So the gist of this is practically, if you have a vending machine, right? You have a vending machine and there's some things in there like there's Skittles and M&Ms and the Skittles, M&Ms and like Paydays or whatever. When you press a certain button, when you input something in the vending machine, wouldn't you want to know exactly what you're going to get back, right? It's not like a toss-up. Like if you press A4 for M&Ms, you want to make sure you get M&Ms. But if you press A4 the next time and you get Skittles, you're not getting what you want. You're paying for something that you don't really want, right? And that's what makes it not functional. So the input has to give you something unique than in the output. So let's look at this. Ready? So like number one. For number one, I'm going to look at all my inputs. My inputs are in green. I made that easy so you could see. My input is my x. So when I look at all my x's, do all my x's go to exactly one y? Well, 3 goes to 2, good. 4 goes to 4, 5 goes to 6, 6 goes to 8, but 6 also goes to 12. We cannot have two of the same inputs. We cannot have the same input get you two outputs. So this is not a function because of the 6's. Okay? Now let's look at number 2. I'm going to call it number 2. Okay? We have yes or no. So let's look at it. We have 4 goes to 4, negative 3 goes to 5, 9 goes to 9, 7 goes to negative 3, 12 goes to 7. So when I look at this, are all my inputs different? Yeah, every button on that vending machine is going to take me to a new snack. And no button's going to get me two of the same snack. Because I don't want that. Like, I'm allergic to peanuts. Why do I don't want a Reese's Pieces? So this is a function. Now, the next one's kind of a tricky one, in my opinion, right? Each input is different, but the output's the same. Does the output being the same matter? I'm going to say no, because one of these vending machines, right? Yeah, they got Snickers and they got M&Ms and Reese's Pieces and Laffy Taffy, but there's two. What if there's two different buttons for Hershey's? Well, Hershey's is just very popular, right? So if there's two different buttons for Hershey's, they can get you the same thing. You can press two different buttons and get the same thing, but it would be dumb if you pressed one button and got two different things and not know which one you're actually going to get. So this one is a function because all of these are different. And then for number 4, I'm looking at it. I got 2 negative ones in my inputs. So sometimes when I press the button in the function machine, I get 6, and sometimes when I press the button in the function machine, I get 12. I don't know which one I'm going to get all the time, right? And that's bad. We want to know for sure when I press this input, I get a certain output. And that being the case, this is a no because we have both negative ones. I know I'm just speeding through this, but you just want to make sure all of your inputs are the same. All your inputs, not the same. All your inputs are unique. Let's move down to the next step. Now we're looking at a chart. Well, I'm going to look at these 3 right here. Boom, right there, okay? Now, when they give you a chart, it's the same idea. We only look at our inputs to make sure we get a unique output. So I'm looking at this. Is this a function, yes or no? I'm going to say no because a 0 can get me 3 and a 0 gets me a 4. We don't like that. So this is not a function. Not a function. Now, what about number 2 in the middle? Are all my inputs different? Yep, all my inputs are different. Check is a function. And then that last one, we'll only care about the inputs. To know whether something's a function or not, we only care about the inputs. We want to make sure that each button you press on that vending machine will take you to a different snack. Boom, check. Nice and easy. And moving down to the last set. Now this is called mapping. I did not map these. Let me map these right quick. This goes here and here. You go there. You go there. You go there, that's kind of sloppy. Give me a second. Let's do this again. 1 goes to 0. 2 goes to 1. 4 goes to 4. 5 goes to 4. 8 goes to 0. Is this a function? Do all my inputs take me, is there only one road from the input to the output bubble? Well, if I look at this, 1 only has one road coming from it. So 1 is a functional input. What about 2? 2 only has one line. 2 is a functional output. 4 only has 1. 5 only has 1. 8 only has 1. Chuck, this is a function because each input only takes you to one output. Now that's in contrary to this one. Let's look at this. I know it's kind of sloppy, but 12 only takes you to one road. 12 only has one thing come from it. I'm cool with that. 8, I'm cool with that. 6, I'm cool with that. 4, I'm cool with that. But when we look at 2, one input takes you to both 6 and 7. That was a bad choice of words, but when you put one input in, you don't know which road you're going down, right? You need to know functionally which way we go from here. This was just a little introduction into functions when it comes to points. I hope you guys picked up something, and I will catch you guys later. Bye-bye.